What'd you get?
For what one?
973.
Thank you. I asked you to add them all together and you go for which one? 973. Thanks, Tyler.
No problem.
Alright, so now we're going to find our sample proportions for the class. So we're going to take the total of the number divided by the grand total. So for red, we're going to take the total, 207, and we're going to divide by the 973 to get our p-hat for red. 207 divided by 973. 0.2, let's go to decimal. We'll go 3. 2, yeah, we'll go 3. 213. 0.213. So I want you guys to find the sample proportion for orange, yellow, green, purple, and I'm going to randomly call on 4 of you to make sure you do. And yes, if you need a calculator, you'll need one. We're going to do lots of significance tests today. Well, I gave you Skittles, so you can't be too mad about it.
That's not true at all. Oh.
Are you already done with yours?
No.
Oh, then why are you trying to take my Skittles?
It was just my intrusive thoughts. Whoa. That's so weird. What is this? What does this belong?
Oh, goodness. Maybe you should have gotten up and gotten your own calculator.
Facts.
That's what I'm doing. I'm so upset with you.
I've been
No, shut up. Oh my god.
I kind of wish I had popsicle sticks with your names right now to randomly pick.
I'm not even done yet.
I'm going to go with Eric.
Oh, I see.
All right, Maddie.
What? Wait 1 second. For what one?
Orange.
0.225.
Thank you, ma'am. Amelia. Yellow. Thank you, ma'am. Hayden. Green.
I got
He's got a mouthful of Skittles.
0.203.
Thank you, sir. Eric. Purple. Pause.
Oh, wait.
How are you doing, bro? I'll just get down. 0.172.
Can I round? So I got 0.173. All right. So like I said, we're going to do some significance tests. By the way, I didn't read the top. So if you go to their website, Mars Incorporated actually says that Skittles have a certain proportion of each color in the bag. Roughly, you know, each bag technically is a random sample, so it's not going to be exactly perfect, but they say they do 25% are red, 20% orange, 15% yellow, 25% green, and 15% purple. So we're going to test their what their claim of the proportions. So we are going to use class totals when it comes to our significance tests. So we're going to be using this column here, use the class totals. Why do we want to use the class totals rather than your individual totals? Say it louder. Bigger sample size. And if we have a larger sample size, what does that do for us? reduce variability. Who said that? Thanks, Jillian. So that's why we want to work with the class totals. I hope I spelled that right. I don't know. All right, so the first one we're going to look at. We seem to think that the proportion of Skittles that are green is different than the manufacturer's claim. So they claim 25%. Our class total was about 20%, so we think that it's different. So to test this, we're going to use what kind of test? How many proportion? Yes, it is a significance test. How many samples are we looking at here? One. And is it a proportion or a mean? Proportion. So we're going to use a 1 prop Z test. Now, I'm going to be somewhat nice here. I already gave you a bag of Skittles, so I guess I'm being super nice here. We're going to state, we're going to skip the plan part. Are you guys okay if we just assume all the conditions are met?
I'm fine if that's okay.
And then we're going to paraphrase our conclusions. We don't have to write our novels, okay? But the state and the do, we're going to do like normal. Well, kind of like normal. We're going to kind of skip some parts on state. We're going to try. Are you okay? Did you sneeze out a Skittle? All right. We're going to start with state. So, significance test. We need to give our hypotheses. So when you're looking at, we're going to assume that the manufacturer, I don't know why I couldn't say that word well, came out really slow, is correct. And they state that you get 25% green. So we're going to say P equals P, that was a crappy P, equals 0.25. Now, in the problem, it says that we think it's different. So what's our alternative going to be? Not equal to. What's our alpha level going to be? And then what's our p hat? Thank you, Hannah. And I'm going to put a G, so we know it's the p hat for the green Skittles. 0.203. And we'll be done with state. Usually we should define the parameter would be the true proportion of green Skittles, but we're not going to write that out. And then we talked about how we're going to skip the plan part and go to the do. We're going to assume all conditions are met. So now we're going to do. You guys are going to do. Because you don't need to watch me do this. You've done this before. So you need to draw your picture. And how about you don't have to give me the test statistic formula. Just tell me what P and Z equal. And then make your conclusion. So draw your picture. You should find your standard deviation, right? So our mean is 0.25 because we're assuming H null is true. Find your standard deviation, find the p-value, find your z. Z equals, p-value equals, draw the picture, all that jazz. I don't need to do it for you. And then conclude, you're going to just do the bare bones of the conclusion. Say that again.
This part, do I use this?
Use this one.
Is it just one?
Yeah.
Where's the X?
That's the S one over the. No, it's the P and then it's 1 minus P over N. See right now.
Yeah. For those of you that forgot, you'll do the square root of P times 1 minus P divided by N. P is 0.25, N is 973. You should, that's what I got, 0.0138, so I'm going to go with 0.014. I like the bottom version. Did you do that on purpose?
Nope. Sorry. Why is it inside the explanation? 8e to the negative 4.
Where is this?
That was a while ago.
Oh. Gotcha.
I got 8.
It's just 0.000.
Point 000.
3 zeros.
But it's so small. This should have a negative E times negative.
E to the negative. 8 times 10 to the negative 4.
Yeah.
should do,
I got 8.8.
so do I just write? So should I just write that?
8.07.
Yeah, or you can put .0008.
This is 80 cents.
Or put in the negative 4.
They're playing my pocket down there.
It's a fucking ball.
Go without the 8.
But could I write it the other way too?
Yeah.
Sure.
That makes more sense.
Me too.
That means it's less than yes. Much less than. What was that? I said 8.1. Oh,
I know where you took stats from.
No, please no.
Oh, then that would be
I went with
so small.
I know, this made more sense to me though.
yeah, it's really
Oh my.
Oh,
Do I have to change it? Birthday being
Usually use .25.
I forgot.
We're using .25. So you want to use 8. We're going to use that in the standard.
Give you the
formula.
value
That
of
was
is true. Then you need to put one of the C to P.
One prop C test, number 5.
There is a
I'm going to
stop. Chance of getting
Bless you.
Thank you. So what? There's a
yeah, because that means you're going to get your decimal towards the left. Excuse me, I said the wrong direction. Will you go do the juice?
Oh.
Is it stronger? It's less.
No, I'm protesting.
Do the bare bones conclusion.
It's protesting.
Wait.
Excuse me.
Yeah. It's what I said. You say stronger than somebody say because alphas.
I actually did some.
I mean,
So there were a few questions about this. Remember the E in scientific notations, really it's telling you 8 times 10 to the negative 4, which really then just tells you to move your decimal 4 to the left. So it's .0008. And the area is so small you can't even really color anything in shade.
why did you stop?
I told you
It wasn't funny.
mystery for me.
Wow. You did more than I expected.
Yeah, we did the whole thing this
Maddie's going to conclude for us. Woohoo, Maddie! Go, Maddie, go.
I'm just gonna put that right there. Where's it?
My mental health is very
Ow!
I'm so sorry. That's very unfortunate.
I don't know if
X is when I wait, where is it? And there's 973.
I'm assuming Molly's going to sit behind you.
yeah.
We were basically half naked swimming in a pool and it was 30 degrees, so
Yeah.
that's like basically. Yeah.
I was telling Sal about that. And he's like, oh, so come on. I'm like, you didn't do that? No, I
Sometimes us lawyers.
Oh, you're writing the whole thing?
Yeah,
Yeah, you got
sorry.
She looks like a hair frame.
I know.
He said bare bones.
Maddie's not very good at listening to directions.
Thanks.
Wow.
Called out.
You're just gonna let her talk to you like that? Like,
No,
How can we write it in your language?
my language?
Yes, in your paraphrased language.
I would have just done P is less than alpha.
Weak evidence.
No, that's strong evidence,
Strong evidence reject H null.
pretty much. And then I would say we conclude that the proportion of green is different than 0.25. Eric?
I'm so thirsty.
Boom. Done.
Are you parked?
Thanks, Maddie. So this, I would have focused on strong evidence against H null. P-value is less than alpha. We reject H null, and therefore we would conclude that the proportion of green is different than 0.25.
That's what I got.
Good. Glad, Hayden.
no one asked you, Dana. I ran out of space here. Oh.
All right. Any questions before we flip to the back? All right, now we're gonna compare two proportions. So this was like chapter 9. Now we're gonna compare two proportions. That was like chapter 10. And then problem 3, we're gonna get to chapter 11. So if you go back to the front, notice that red and green are claimed to both be 25% of the bag. So we're going to see if that's actually true. So we're going to test the claim that the proportion of red is the same as the proportion of green. We think, don't put that one in your mouth, Zach. Okay. No, it's been much longer. We think, based on our data, that the proportion of red is greater than the proportion of green because we have 0.213 for our class proportion for red and 0.203 for the class proportion for green. So we're going to say that we think the
Listen, the proportion of red is greater than the proportion.
Oh, thanks. But I can't fit greater than in that little line, so I'm going to say more than.
I can too.
So when we compare two proportions, what's our test called? Two prop Z test.
Yes.
You tell them.
Exactly.
So same thing, really small state, just give me the hypotheses, the alpha level, and your p hat G and your p hat red. Then do the do, and bare bones conclusion. You don't have to be as wordy as Maddie. Maddie likes to talk. So she put a
What's the manufacturer's proportion of red?
0.25.
Oh, I see.
Well, on the state, what is your null hypothesis, Hayden?
My null
Oh, yeah.
hypothesis?
Yeah.
0.25.
No. You're there. I cannot speak today.
That's okay.
The manufacturer claims that red and green are the same, so you would say the proportion of red equals the proportion of green. But based on our sample, what do we think?
No.
Red is greater than green.
Do we have to say that like P1 is red and P2 is green?
No, I used RNG
Oh.
to kind of keep it. And then alpha, we're going to use 0.05. And then P hat red was what? 0.213? and P hat G. It's on the front of your paper. I know G, the green, is 0.203. Red was 0.213, right? Yeah. All right, and then I'll let you guys do and conclude from there.
It's zero.
Oh, you need a picture?
She's in her order. Zach, what are you doing?
Why are you snitching on me?
I'm just
doing anything.
doing. Please.
He's making a mask so when he spies on you, you won't know it's him.
Wait, do it again. Who is it? It's not Willow. Yeah. It's Zach.
Laptop was.
Zach, you're gonna draw like a face on the
I know.
back of the plate.
Okay, I have to do math, guys. Stay focused. Yo.
I don't know why I put plus. Should be minus.
Y'all are confused. Whoa, Julie really said. Whoa. I like Baja Blast.
Baja Blast.
Well, good thing I'm not again.
That vibe, like suggests hormonal freedom.
It looks like an actual face. Really? It is funny. You'd say there's like a deeper meaning behind it, and like if you're in art class, you get like extra credit.
This is my deep emotions.
You should talk to people, and whenever you say something, make the pen go out further, like your Pinocchio. Like say Miss Little is a good teacher, then push it forward.
Oh! Wow. Oh, wow. Hey, he said,
F for the corner.
I think you're a great teacher.
I think you should draw some eyebrows on there. What's with his smile? Is he having like a stroke?
Sure.
Look, it's drooping.
One side is
One side is
Give it to the
drooping.
doctor.
It's skewed to the left.
And you say I'm not a good teacher.
He knows it's huge to the left.
our fault.
Now he's just making random noises. Please read.
Read.
Tell Molly I miss her.
I will.
I didn't know I had to keep tapping. Ah!
No, she's not gonna respond. There we go.
Oh my. I don't even know.
Am I supposed to go in there? I don't get it. Yeah.
No, you want to do. So if this one and this one. Yeah. So yeah, it is this one type of color.
Yeah.
Yes. But you run it like I don't.
Yeah.
Sand it out. Sand called the broken tensor everywhere.
This one.
So then it's in the first.
Watch me now.
I should Sam.
So.
Oh, was it like shrimp flash?
No.
I like how you
Oh, I'm so close. Oh, I don't know how to spell it.
do sample sizes 970.
I can't spell word. I think
Oh my. Oh my. Tu papitas.
Will you
Tu
go
papitas.
do draw the picture of that with that?
Everything is the whole.
Alright, Anna's gonna do the do for us.
Tu papitas.
my colors.
What to do?
Listen. I just want to send this. This is fun.
Did you bare bones conclude this time?
No.
You fully conclude?
No, I. Oh.
She's like, I did twice as much last time, so I'm doing nothing this time.
Yeah, sounds about right.
Wow.
It evens out. Also, Molly says she misses you too.
Skittle day.
I know. Poor Molly.
Seriously.
No one stands.
This is so funny.
I showed my teacher this and he didn't think it was funny.
It's, wait, who did you show?
Heather.
What?
You want to see this TikTok? I want you to see it.
Oh, okay.
You get it right through your arms.
Oh, my.
So you don't have to right or have arms.
Do we hold these arms on a bear? Or
Yeah.
do they have 4 legs?
It's
Bears literally walk on their
It's just a
back
joke.
legs all the time, just like that. Just walk. Have you ever seen that?
it's called, it's supposed to be.
Have you
My
ever
dog
seen
can
a
walk
bear?
on. My dog can walk on him.
Have you ever seen a bear?
Your
I
dog's
have
a
seen it.
Only
skinwalker.
captivity?
No, in real life, my grandma lives in Montana. I've seen bear and bear cubs. It was like actually dangerous, but it's
Montana.
Oh, bears. I've
What does
never
it do in
seen
Montana?
one out in the wild.
Go to Montana.
That's it.
Archaeology.
But
Alright,
my dog.
Shelly's gonna bare bones conclude for us. She knows how to follow directions.
She's unfazed. She's playing on her phone.
Yeah, she is.
Sorry. I'm playing in color here.
Doing home design.
Oh.
Yeah, I do play games on my phone.
Well, yeah, what else would you do with your phone? Make phone calls?
Oh.
Nobody does that.
Oh.
Rarely.
If I have to, I don't do it. Figure out more.
Yeah, I would run another text.
Me too.
Actually, don't.
You're talking to anybody on the phone is
I know.
weird.
Yeah, but like, you know, if it's like my mom or like one of my
Just
like,
yourself.
I was in all my appointments like over the phone.
Well, yeah, when I have to make an appointment, I have to call. Like, I have to call to make an appointment today. Thanks for reminding me. I gotta do that at lunch.
No.
But, yeah, so I'll call. Doesn't mean I enjoy it.
Yeah, I
I
don't
could just
know.
sit next to my sister and put in contract.
Well, like, I'll text my mom. My sister, if I call her, I'll be on the phone for an hour and a half. But if I text her, it's nice
And
and
I'll be back
simple.
a second.
But my sister, man, She'll just keep talking. Talking.
No. It's okay with it.
All right.
Like the desk.
Just
So-
hang up the phone.
I literally, I love my sister, but she likes to talk. And so sometimes I just sit there with the phone on my ear and and it's like she doesn't even realize I'm not talking. All right, so Anna drew our picture, p-value 0.3076, z-score of 0.5026. Shelley concluded our p-value is greater than or equal to alpha, so it doesn't provide strong evidence against the null. So we failed to reject the null, so we conclude that the null, the proportion of red, is equal to the proportion of green. We're going to believe the manufacturer here. Problem 3, we want to compare all of the manufacturer's claim proportions to our sample proportions. We seem to think that all of our proportions are different. They say 25% red, we got about 21. 20% orange, we got about 22.5. 15% yellow, we got 18. 25% green, we got 20, and 15% purple, and we got 17. So based on our sample, we would think that all of the proportions are different. So when you want to test multiple proportions, we use a chi-square Goff test. Goff. Goff. Did you think I said goth? Yeah. Yeah, chi-square Goff test. No, Goff. And I know Nathan said I say it wrong, but I say chi-square.
So it's like a wonky X.
It's a wonky X, yes. And it is spelled C-H-I. And it's square, not squared, chi-square. And then Goff is goodness of fit.
Huh?
For goodness.
Goodness of fit. We're going to go over a chi-square Goff test in more depth tomorrow. So don't think this is the only time you see it. But that is what we're going to look at today.
Goodness.
Wait, I thought you said goodness of fit.
Yes.
Oh gosh. That's
Oh,
why I
gosh.
shouldn't talk and write.
Oh, God.
Goodness of fit test. It is. It's a goodness of fit test. Sorry. Thanks, Hannah. It's Monday.
Yes.
It's the 4th quarter, though.
Yeah.
We're 3/4 of the way done. All right, so in this test, what we do is we compare our observed data and our expected data.
It probably doesn't. I also
So first thing, we're going to go through and fill out this table, and then we're going to do this significance test together. So claim distribution, that's what the manufacturer claims. Ah, sorry, that line has a wacky dip in it. So the manufacturer claimed 25% red, 20% orange, 15% yellow, 25% green, and 15% purple. Our samples, somebody want to read me our proportions, please, so I don't have to flip back and forth.
0.213, 0.225,
Slow down. Okay.
186, 0.203, 0.173.
Thanks, Hayden. And then our observed, that means the actual count of our data. So we're gonna go back and we're looking. Somebody read me the actual numbers, the class totals, please. How many red did we observe? Maddie?
207.
Thank you. How many orange?
219.
How many yellow?
181.
How many green?
198.
And how many purple?
168.
Thank you, ma'am.
You're welcome.
Now, our expected. Are we okay, Eric?
Sorry,
Okay. How would you guys find the number that we expected to have that were red, orange, yellow, green, purple?
Times the 0.25 to the sample size.
So we're going to take the claimed distribution, we're going to multiply it by the sample size like Jillian said. Thank you. So your sample size is n, and you're going to multiply it by the claimed distribution. And I can't fit distribution. So our sample size was 973. And we're going to take 0.25 times that. And we get 243.25, which is what we would have for green also, because that was 0.25. And then orange is supposed to be 20%, so 0.2 times 973, which is 194.6. And then yellow and purple are both 0.15, so 145.95. Now we're going to add a couple columns. Anybody take AP Bio? Is familiar? What would be the next step? Do you remember? I know he teaches it at the beginning of the year.
Yeah. Don't you, like, minus the observed from the expected?
You take the expected from the observed. So we're going to take the observed number and we're going to subtract the expected. So 207 minus that, 219 minus that. You guys want to find those 5 numbers for me. And I'm going to call on a random 5 people. Eric, you're one of them.
What?
Do some math, Eric. He's like, dang, I have to do math.
Wait, what is minus again?
Say that again, I'm sorry.
What is minus observed?
Expected?
Okay.
So it's just like 207 minus 243.
Mm-hmm. Oh, observed minus expected. Sorry. I can see where you would think that's 0.
It's 0 minus.
That would be really simple though.
Yeah, all of them would just be negative expected.
Mm-hmm.
Wait, it's not a 0?
No, it's, the observed number minus the expected number. You guys ready for me to start calling on
No.
people?
No,
Oh, come on. You gotta have the first number
it's just
done.
subtraction.
Yeah.
It's from the guy who's got the scrunched up confused. It's just subtraction. All right,
It would say.
Tyler. Tyler, do you have the first one for us, please?
Thank you. Negative 36.25.
Thank you. Zach. Orange.
Oh, sure.
24.4.
Thank you. Cheyenne. Yellow.
35.05.
Thank you. Anna, green. Thank you. And Jillian.
22.85.
Thank you. And then Amelia, do you know what the next step would be? Do you remember? I'm putting you on the spot here. No, we're not to the sum yet. Now we have to square. So we're going to take the observed minus the expected and we're going to square them. So we're just going to square those numbers. And I'm gonna let's go to 2 decimals. So that, if you want to write more than that, you can. Oh. Well, sure, go ahead, go to 1. My hole punch is in the way.
Yeah.
Down at the bottom, I put the actual formula, except for my E is really funkadoo. Sorry. For chi-squared. This means sum. So they take the sum of the observed minus the expected squared, and they divide by the expected, and that will give you your chi-squared value. Now, if you took AP Bio, Mr. Almanza taught you how to do all this by hand, but the calculator does it for you. So, I'm going to show you how to do it in the calculator.
Yes.
We are going to state, we're going to do it all. The plan is slightly different per chi-square, so I want to show it here. So, state. Our null hypothesis here is that the claimed distribution is correct. You may see it written out. Well, hold on. I'm going to write this and then I'll show you what sometimes it's shown as. But right now, I'm using words because the distribution that the company claims, red and orange are the same, yellow and purple are the same. I said red and orange. Red and green are the same, yellow and purple are the same, and then orange is different. A lot of times with a chi-squared goodness of fit, they're all going to have the same proportion. And so we would say something like if they were all 0.2, because there's 5 colors, we would say something like proportion of red equals the proportion of orange, which equals the proportion of yellow, which equals the proportion of green, which equals the proportion of purple.
Huh?
But I prefer to just imagine this. I prefer words for once. And I just like to say the claim distribution is correct. The null, or excuse me, the alternative would be that the claim distribution is not correct. We think it's off. And our alpha is going to be 0.05. State, or I keep saying state instead of plan. I don't know why. My brain's just still on the weekend. So for a plan, we state the calculator function, so it's the chi-square Goff. Random, we're going to assume that a bag equals an SRS of Skittles. Independent is that sample size is less than or equal to 1/10 of the population. So our sample size, excuse me, was 973. So when we multiply by 10, 9730, we're going to assume there's more than that many Skittles out in the universe, because there is. And then instead of normal, we have what's called the large counts. And the large counts is really just making sure that our expected are all greater than 5. If we have an expected that's less than 5, then the condition isn't met. So the expected count of red, orange, yellow, green, purple, we expect more than 5 Skittles for each of those, so our large counts condition is met. Now, on the do, you need to draw a picture. It is not a normal curve. It is a chi-square curve, which you're going to have the origin to the left. And it's a wonky curve. You have the majority of the distribution to begin with, and then it skews off to the right. We're going to go over more why it looks that way tomorrow. So now we're going to have the calculator find the chi-squared value for us and our p-value. So when we put it in there, we're going to get what chi-squared equals. We're going to talk about the degrees of freedom, and we're going to get the p-value. I guess I'll talk about degrees of freedom right now because you have to put it in when you do the chi-squared test. So degrees of freedom, we have in our claim distribution, we have 5 proportions, so our degrees of freedom is going to be 1 less. So 5 minus 1, which is 4. Just like any other test, you're going to go into stat, go over to tests. Might be easier if you scroll up. There's chi-square Goff test, D. Oh, I forgot this part. I always forget this part. Sorry. We need, what? We need to put our observed and our expected in our lists. So put the observed in list 1, expected in list 2. Observed 207, 219. Oh, come on. Stop with the size. Gosh. 243, 190, oops, 194.6. Then go back into the chi-square Goff. And you should have the observed in list 1, expected in list 2. Degrees freedom is 4. Are we good?
Wait.
Say that again? I don't know, I haven't done it yet.
Oh, what's his name though?
Are we good?
I got 28.
I got 28.53.
I'm gonna have it draw for me. See, there's my chi-square. It's all to the left and then it's skewed to the right. Chi-squared is 28.62 and our P is 0. I hate it when it does that. I'm gonna go back in and have it calculate. When you draw, if it's a really small p-value, they just say 0. But if you go to calculate, it'll actually give you a p-value. So chi-square is 28.63. P-value, we have this e to the negative 6 behind it. So 0.000009. 5 zeros, then my 9. And then, same as a conclusion for any other significance test, I'm going to do the bare bones because I'm running out of time. Our p-value is less than alpha, which means we have strong evidence against the null. Yes, sorry, thank you. Which means we're going to reject H null, conclude the alternative, that the claimed distribution is not correct. And like I said, we'll do more with chi-squared Goff tomorrow. Don't follow this homework. Follow the homework on your overview. I think it's slightly different.
Dude, those are close.
Oh no, it's the same.
Oh,
Sorry. Sometimes I update homework and it only updated on my overview, it's not on
no.
this.
I'm all skilled up. Surprisingly.
Whoa, whoa, whoa.
I wouldn't want to do the wrong homework.
You wouldn't want to do homework, period, Hayden.